Let us revise a linear programming problem with joy and confidence. Let us start by writing the objective function and the linear constraints carefully. Then plot the lines neatly and shade the feasible region accurately. Your answer hides there. Every graph you draw, every constraint you solve is shaping your logical mind. The very skill guide your success beyond exams. Check the corner points and substitute them in the objective function. As per the question, whether it is to maximize or to minimize, we choose the maximum value or the minimum value from the table which we framed with the two columns. First column of corner points, and second column is the column of value of the given objective function. In case of the bounded feasible region, and if the question is to maximize, note the maximum value of the objective function from the tabular form which we framed, and it is at which point. If we are seeing maximum value is only at a single point, say capital P, AB, x coordinate is small a and y coordinate is small b, then we say the optimal solutions are x equal to a and y is equal to b, and the optimal value is the maximum value of set which we obtained at x equal to small a and y is equal to small b. If we are getting maximum value of the objective function set at two different points, say capital P, A, B, x coordinate is A, y coordinate is B, and at Q, C, D, that is the point Q has x coordinate C, y coordinate D, then we say that the objective function capital set has maximum value at every point on the line segment joining P, capital P, A, B, x coordinate A, y coordinate B, and Q, capital Q, C, D, that is x coordinate is C, y coordinate is D. And in this case, there are infinitely many optimal solutions which lie on the line segment joining P and Q. In both these cases, there are infinitely many feasible solutions which lie on the boundary lines of the feasible region and interior to the feasible region. Same as in the case of minimizing the objective function if the feasible region is bounded. Suppose the feasible region is the unbounded region and question is to minimize. After making the tabular form with the two columns, in which first column is column of corner points, second column is column of values of the objective function set. Note the minimum value of set. Take it as small u. Also note this minimum value u obtained at which point, at which corner point. Next, draw an additional dotted line segment for capital set strictly less than u, where u is the minimum value which we obtained and capital Z is a given objective function. If this dotted line segment doesn't pass to feasible region, then we say that the minimum value exists and it is u. If this dotted line segment coincides with any one of the boundary lines of the feasible region also, we can conclude the minimum value is u. But if the dotted line segment passes through the feasible region, we conclude that there doesn't exist any minimum value. Therefore, no optimal solution. In the same way, we can tackle the question to maximize also in case of unbounded region. In this case, draw the additional dotted line segment for z is strictly greater than v, where z is a given objective function and v is the maximum value which we obtain from the table. If the additional dotted line segment doesn't pass through the feasible region, there exists the maximum value and it is the same v. If the dotted line segment coincides with any one of the boundary lines also, the maximum value is v. If it crosses the feasible region, if it passes through feasible region, there doesn't exist any maximum value, therefore no optimal solution. But there are infinite number of feasible solutions which lie on the boundary lines of the feasible region as well as interior to the feasible region.